Hello everyone. Today I'm gonna discuss about the diesel cycle. Diesel engine, it is also known as the compression ignition engine. Can this engine knock or the different? What is its difference from the Otto cycle? So here is a simple. I don't think it's simple. It's a sample picture for the diesel engine. So here is the actual cycle of the diesel engine where first is the intake stroke where air goes in the cylinder, and then next is the compression stroke where the air is um, compressed, and then next is the power stroke where the fuel injected at the cylinder, um, then we have the combustion which um, pushes the piston downwards, and then here's the combustion products going out of the outlet. So it is here, the air, and then compressed adiabatically, and then it explodes from the combustion. It expands, it pushes the piston downwards, and then the piston pushes the byproducts of the combustion outwards. So process A to B is isentropic compression. So from A to B, so here's the input where we get um, the air. So from A to B is the isentropic compression, and then B to C is the isentropic expansion, same entropy. B to C is constant pressure. Um, so from process B to C is the constant pressure heat addition. So where the heat is added for the combustion. Then from process C to D is isentropic expansion, same entropy, but it is expanding. So the volume varies. So here we go. So from process D to A is the constant volume heat rejection. So the temperature decreases. It is where the heat is rejected. So for the thermal efficiency is 1 minus Q out divided by the mass over Q in, or the inward heat addition, divided by the mass, which we can cancel, which is equals to U4 minus U1 over H3 minus H2. So for cold air standard, the above reduces to this. So now we have the new, we can derive from this, we can get this formula, and then as we can see, from the efficiency of the Otto cycle, we have almost identical. We just had the addition of 1 over k times RC over RC, which is almost the same. But in terms of the square brackets, is always larger than the one. So for the same compression ratio R, the diesel cycle has a lower thermal efficiency than the Otto cycle. So why is a diesel engine usually more efficient? So when the RCs is the diesel cycle efficiency approaches the efficiency of the Otto cycle. So here, higher efficiency is obtained by adding less heat per cycle. So running an engine at higher speed to get the same power. So the cutoff ratio is not a natural choice for the independent variable. A more suitable parameter is the heat input the two are related by. So this is the K 1.3, then this is the formula for the cutoff ratio. So the mean effective pressure is the work net over volume maximum, or the total volume minus the volume displaced, or the clearance volume, or simply the volume displaced. So the network divided by the volume displaced. So here are the basic formulas for the diesel cycle. So for the heat added, QA is equals to M constant pressure times T3 and T2, since the heat addition happens from point 2 to point 3 where the combustion starts. And then heat rejected is MCV constant volume, um, from T4 to T1, since the temperature decreases at from point 4 to point 1. So the heat is rejected from that process from point 4 to point 1. So the total network is, as usual, the heat added minus the heat rejected. And then the cycle efficiency is the total work divided by the heat added, or the heat added minus the heat rejected divided by the heat added. And as we have discussed earlier, the other formula for the efficiency is 1 minus 1 over RK raised to K minus 1 times the quantity R, the compression ratio, or the cutoff ratio, raised to K minus 1 divided by K times the cutoff ratio minus 1. So the compression ratio is the RK, which is the V1 over V2, same as the Otto cycle. So the cutoff ratio is V3 over V2. So for the specific heat ratio, K is 1.44 air standard. So the clearance ratio is the V2 divided by volume displaced. So it's the same, V2 divided by V1 minus V2. So volume displaced on a cylinder, if the diameter is given, you have pi over 4 times the diameter squared times the length and the speed. Okay, that's the end. So the mean effective pressure is the work over the volume displaced. So that's it. Thank you.